In this video, we are going to be going through the June 2023 Geometry Regents, questions 1 through 12. Okay, number 1, a square pyramid is intersected by a plane passing through the vertex and perpendicular to the base. Which two-dimensional shape describes the cross-section? Whenever the cross-section is perpendicular to the base, it's going to be the same shape, the cross-section will be the same shape as the sides. And by the way, if it was parallel to the base, it would be the same shape as the base. So the sides of this shape are triangles, so our answer is choice 2. Number 2, trapezoid ABCD is drawn and AB and DC are parallel. So I'm just going to mark that in my picture. Trapezoid A prime, B prime, C prime, D prime is the image after a rotation of 110 degrees counterclockwise about point P. So remember, a rotation is a rigid motion. Rigid motions preserve distance and angle measure. We want to know which statement is always going to be true. Choice 1, angle A and angle D are congruent to one another. There's no reason for us to believe that these two angles are congruent. They are not corresponding angles, so I'm going to cross out choice 1. Number 2, AC is congruent to B prime, D prime. Those are two diagonals, but again, they are not corresponding line segments, so we have no reason to believe those are congruent either, so I'm going to cross off choice 2. Number 3, A prime, B prime is parallel to D prime, C prime. That is going to be true because when you have a rigid motion, parallelism is preserved. It's still a trapezoid, so our answer is choice 3. And we're going to rule out choice 4 as well because B prime, A prime, and C prime, D prime are not corresponding sides. Okay, so to summarize, our answer is choice 2 because parallelism or slope is preserved. Number 3, what's the volume of a right circular cone that has a height of 7.2 centimeters and a radius of 2.5 centimeters to the nearest tenth of a cubic centimeter? So you would go to your reference sheet for this, and you would find your formula for volume of a cone, which is 1/3 pi r squared h, and I'm going to substitute in our values for r and h. And then I'm going to simply just go to my calculator here, and I'm going to type this in. We are typing pi in the calculator. This is not in terms of pi. We're going to have to round. And I have 47.12388 and so on, and that is going to give me choice 2. Number 4, in the diagram below of right triangle SUN, where n is a right angle, SU is 13.6, SN is 12.3. What is the measure of angle S to the nearest degree? All right, this is definitely going to be a right triangle trigonometry problem. Here's our opposite side, our hypotenuse, and adjacent. So we'll be using the ka part of SOHCAHTOA. So the cosine of angle S is equal to the adjacent side over the hypotenuse. And whenever we're finding an angle, we are going to do the inverse operation in our calculator. So I'm going to hit the second button and then cosine. 12.3 divided by 13.6. And we're looking to the nearest degree, so choice 1, 25 degrees. Just one note on that question, everybody. If you go to your mode, you want to make sure that you are always in degree mode here when you are doing a right triangle trigonometry problem. 5, in the diagram below of circle O, diameter AOB and chord CB are drawn. We see angle B is 28 degrees. We want to know what the measure of arc BC is, so we are looking for this piece here. First, what I'm going to do is I'm going to find the measure of arc AC. This is an inscribed angle, and an inscribed angle is always going to be half the measure of the arc it intercepts. So I can tell that this arc is going to be 56 degrees because that is double that inscribed angle, or you could think about it, the inscribed angle is half of that arc. 28 is half of 56. Then notice here that we are given the information that AOB is a diameter. That means everything here must be 180 degrees. So I'm going to do 180 minus 56, and I'm going to get choice 2, 124 degrees. In the diagram below of parallelogram ABCD, we have diagonals BED and EF. We know EF and DFC are perpendicular. So when I see this perpendicular symbol right here, I know that means that there are right angles. So I'm going to go ahead and put them in the picture. The measure of angle DAB is 111. That's already in the picture, as is angle DBC being 39. We want to find the measure of angle DEF. So I'm just going to highlight in the picture here. I'm just going to put like a little circle in here to note that's the angle that we're trying to find. Really often in an angle problem like this, you can't find the answer immediately. You have to find other angles in the picture and kind of work your way towards it. So kind of like a little puzzle. So I know that in a parallelogram, the opposite angles are congruent. So if angle A is 111, I know angle C is also 111 degrees. Then I know that a quadrilateral always has a sum of 360 degrees. So I see here that this quadrilateral has 3 angle measurements that we know. So I know 39, I know 111, and I know 90. Subtract that from 360, and I know that this angle here is 120. Finally, these 2 angles are supplementary. They're on a straight line. So we have found our missing angle, which is choice 3, 60 degrees. As a tip, let's say you got this problem and you have absolutely no idea where to start finding missing angles. Look at the angle that you're trying to find in the picture. You can definitely see it's an acute angle. So I would have ruled out choice 4. Number 7, in the diagram below of triangle ACT, we have ES and AT that are parallel, and we want to know what statement is always true. These questions can definitely be a little tricky to work through, but what I would consider is that this line here, since it's parallel, this is what we call a side splitter. A side splitter splits, hence its name, those 2 sides proportionally. So I know that CE over EA has to be equal to CS over ST. It's basically the left side, the 2 pieces, the right side, the 2 pieces. And I'm going to check to see if that's an answer choice. Sometimes it is, sometimes it's not. But it does happen to be here, so I know my answer for 7 is choice 3. Number 8, on the set of axes below, we have congruent triangles ABC and DEF are drawn. And we want to know what sequence of transformations maps ABC onto DEF. Well, when I look at this, I can definitely see that there's some sort of rotation going on. And I see that if I look at my answer choices, they all have rotation in them. So while that's a good thing to notice, that's not going to help me eliminate any choices here. However, when I do look at those answer choices, I notice they all start the same way. A counterclockwise rotation of 90 degrees about the origin. Each of the 4 answer choices basically the first 3 of the 4 answer choices, have that, and choice 4 has clockwise. So let's start with the idea that it's probably counterclockwise rotation of 90 degrees to start. Okay, so that basically means I'm rotating this triangle about the origin 1 quadrant over. Okay, so if I do that here, and if you struggle with this and you're better at memorizing rules, here's what I would suggest to you. Write down the coordinates for ABC. So -2, 6 is A, B is -2, 2, C is -5, 2. When you rotate them, each of these points, 90 degrees counterclockwise about the origin, you're going to negate the Y value and switch the coordinates. So let's say I do that to each of them here. Now I have some points to plot. Okay, you do not have to do it that way. You're not required to memorize your rules. You could turn your paper, but for me on the iPad, without turning it here, this is the easiest way to show you. And I'm going to draw what that looks like after my first transformation. Now I can see this is pretty close, but it looks like we just have to slide that triangle to the right, and we're going to slide it 8 units, right? 1, 2, 3, 4, 5, 6, 7, 8 units, right? And that will give us choice 1. Number 9, an equation of circle M is x squared plus y squared plus 6x minus 2y plus 1 equals 0. What are the coordinates of the center and the length of the radius? When studying for the geometry regions, this is definitely a question I would make sure you know how to do. They seem to always ask one where you need to do this process of completing the square in order to write the equation of a circle in center radius form. Here's how I start. I'm going to just start by rewriting the equation in the blank space here. And I'm going to rearrange a few things. So I want the x terms to be next to each other, and I want the y terms to be next to each other. So I'm basically flip-flopping these two in here. I'm not moving it to the other side of the equal sign, so I'm not changing the sign. I'm just reordering them. However, I am going to move this 1 over to the other side, because this is how I like to start these questions. I like to have everything with a variable on the left side of the equal sign, everything without a variable on the right-hand side. Okay, now what we're going to do after the first two terms, we are going to put a little blank space. The same thing after the next two terms, and we're going to balance our equation. Now we're going to do the process of completing the square. We're going to look at the coefficient of the x and the y terms, each one individually, have them and square them. So with the 6, if I have it and square it, I get plus 9. With the negative 2, have it and square it, I get plus 1. And remember, our equation must be balanced, so let's put that over on the right. Now I want you to look at this here. We basically have formed two perfect square trinomials. That's what the purpose of completing the square is. So this is x plus 3 times x plus 3 if I factor it. Think about a perfect square like the number 25. There's two identical factors, right? 5 and 5. So we should be getting identical factors. That's the goal of this process. And over here, these ones are going to cancel out. So I get x plus 3 squared plus y minus 1 squared equals 9. And finally, we can get to our center and radius. We're going to take the opposites of the numbers in the parentheses. So that's negative 3, 1. We're going to take the square root of the number at the end, so the radius is 3. So our center is negative 3, 1, our radius is 3, and our answer, therefore, is choice 4. Number 10, parallelogram BETH with diagonals BT and HE is drawn below. What additional statement is sufficient to prove that BETH is a rectangle? So we really have to know our properties of quadrilaterals here. So there's a couple differences about a parallelogram and a rectangle. Okay, we would have to know that consecutive sides are perpendicular. So if I glance at the answer choices, choice 1 has a perpendicular symbol, but that's talking about the diagonals. That's not true in a rectangle, so I don't think that's it. Another fact about a rectangle is that the diagonals are congruent to one another. So that would mean that BT and HE have to be congruent. That actually is an answer choice. It's choice 3, and therefore that's our answer. So we're looking for basically what is a property of a rectangle. 11, a gardener wants to buy enough mulch to cover a rectangular garden that is 3 feet by 10 feet. One bag contains 2 cubic feet of mulch and costs $3.66. How much will the minimum number of bags cost to cover the garden with mulch 3 inches deep? Okay, so I notice one little problem here, and we always want to look for this little trick on the Regents. And I see feet, inches. Okay, so we have to get all these units to match. So since 3 of them are in feet and 1 of them is in inches, let's change the one that's in inches. So 3 inches is equal to 1/4 of a foot, so 0.25 feet. Okay. All right, so the volume of this garden is 3 by 10 by 0.25. So let's calculate that. So 7.5 cubic feet is the volume of the garden. 1 bag of mulch contains 2 cubic feet. So we have to think about how many he needs to buy. So he's going to need to buy 4 bags of mulch, right? 3 bags is not going to be enough. That's only going to cover 6 cubic feet. We need to cover 7.5. And each of the bags is $3.66. So 4 times $3.66 gives us $14.64, or choice 3. All right, the last one in this video, number 12. In the diagram below, triangle DOG is similar. Notice the symbol there, similar to triangle CAT. G and T are right angles. Which expression is always equivalent to the sine of D? Okay, so this question is a little tricky because we're combining actually two different concepts here. We're talking about similar triangles, and we're also talking about cofunctions, which means the sine of an angle is equal to the cosine of its complement. So I want to note here that the sine of D has to be equal to the sine of C because those are two corresponding angles. Okay. The sine of D is also equal to the cosine of O. That's because angle D and angle O are two complementary angles, in a right triangle. That means the sine of one is equal to the cosine of the other. So now we have to think, is cosine of O equal to anything else? Yep, it's equal to the cosine of A because O and A are two corresponding angles, and that's going to make our answer choice 1. Now that can be a hard flow of logic for some people to follow, so here's what I would suggest. If the problem is asking you equivalent to sine, the answer is very likely cosine. Okay, so I'm gonna cross off choice 2 and 3. Then what we need to do is make sure we find the other angle, not the one it's congruent to, it's complementary angle. So since D and C are congruent, we want to pick the other set, so O or A, and then A happens to be the one that's our choice here. You can check out the rest of the answers to this Regents exam in the remaining videos in this playlist. Thanks for watching. Hope it was helpful.